Okay, so I had one question already from previous work. And so I'll do that. And in the meanwhile, once I do that, if somebody has another one, we can, whoops, what happened? Okay,
I'm sorry.
that's okay. I think I messed up. Let me see. Let me stop share. Okay, share, advanced. I think it's because I was playing with the, there. So here was a particular problem. Any number squared, like 2 squared. You just have to write it twice. So if it was 2 squared, it would be 2 times 2, which is 4. But this number squared, you would have to go 3.3 times 3.2 times 3.2. So then I find it easier to write them like this. When you're going to multiply, 2 times 2 is 4, 2 times 3 is 6. Now to do the threes, 3 times 2 is 6, sliding over 1, 3 times 3 is 9. And then you ignore the decimals until this point. This is 12, carry a 1, 9 and 1 is 10. At this point in time, once you get the numbers in place, then you count how many decimal places are involved. In this case, it's 1, 2. So then you would go over 2. So the answer would be 10.24, which is 10 and 24 hundredths.
Okay.
Yeah.
Just go all the way around, right?
Yeah.
Okay.
So you have to count the 2 numbers you multiplied. If you had to go to the third power, you would just have to take that answer and do it again. Take that answer and multiply by 3.2.
Oh,
You have to
gotcha.
do them 2 at a time. Okay. So anybody else have something we could do now? We'll do some review at the end. But if you have something now, let me know. So what I'm going to do is go through, talk about this one. This particular section, we're getting toward the end of this chapter. This is where they've had fractions and decimals at the same time. And so they start with this. They say, take the number 7/12 and turn it into a decimal. And you're going to round it to the nearest thousandths place. So the first thing you have to do, and this is going back to earlier chapters, you have to divide this out. So this is 7 divided by 12. So if you do it like this, you really kind of want to put the 7 here because it would be easier, but that's not the right way. It's dividing by 12, which puts the 12 here, and then the 7 here. And if you ever get confused about which one goes where, you can turn the fraction into a division problem. The 7 would come down, and that would place them in the proper position. So here's a decimal point, and I'm going to add some zeros. In fact, to do thousands, which is tenths, hundredths, thousandths, I'm going to actually need 1 extra. So I'm going to have to go that far. Because this is a whole number, this decimal point can come straight up. And so it's 12 into 70. And so the answer actually is 5, because 5 times 12 happens to be 60. Okay, you can try a few to make sure that's right. You subtract 70 minus 60 is 10, and you bring down that first one. 12 into 100. I'm actually looking at my book. So it's 8. 8 times 12 is 96. So you do that on the side for a minute. You subtract and you get 4. And you bring down that next 0. It gets easier. 12 into 40 is 3. 3 times 12 is 36. And oh my, we talked about this last time. When you subtract, you get 4 again. And when you bring this down, it's 40. So 12 into 40 is 3. And then it's going to keep repeating over and over again. So the 3 keeps going. And so back to the instructions, which were, find this decimal and round it to the thousands place. So what I have so far is 5833. So this is tenths, hundredths, thousands. So I kind of, when I do my rounding, I've kind of made this little mark to say this is the last number I'm going to see on the decimal side. So I have to decide, does the 3 stay 3 or does it go up 1? And it's based on the very next number. So that's why I had to go an extra place. The 3 doesn't shift this up. So what I have is 583. That would be correctly rounded. Now, what we said before about this front 0, I personally would put it in at that point. Okay, so if this had been 5 or more, the 3 would have gone up 1, but because it was on the small side, the 3 stayed put. So this is not an exact answer, because remember the 3s keep going, but this is a rounded answer, good for 3 decimal places. So that part is a bit of a review, I don't know. The reverse of this is if you have a decimal, whoops, and they say, well, won't you round it? Won't you change it to a fraction? So this again is review, but you have to remember how to say this. This is 38 hundredths. So that would be 38 over 100. The problem with fractions is the assumption is you will reduce them no matter what. So I'm going to divide both of them by 2. So 2 into 38 would be 19. And 2 into 100 would be 50. So this would be the answer that they're looking for, even though this one was good, this one is better. And so those are the 2 ways. And so you need to remember that this is the 10th, this is the 100th, and that's why we put it over 100. Let me do a different one. So this one is the same thing we're going to do, but this is tenths, hundredths, thousands. So, you know, if people need to write that down on a page of notes, then that's what you need to do. Tenths and hundreds and thousands if you need it. So this would be 75 divided by 1,000. Now, again, that's not going to fly because this can reduce. And you can clearly see with the 5 and the 0, that would reduce. Now you could reduce it by 5 and then 5 again. Although when you start to think of money, you might be able to see how many quarters, how many 25s are in 75. So if you can see that, then you would say, how many quarters would there be in $10? And maybe you can figure that out. I'm going to do it by 5, but it can be done with 25. So 5 into 7 goes once, 2 left over. 5 into 25 goes 5. And then 5 into this, 5 into 10 is 200. And then there's 2 extra zeros. You see how this goes again, because it's a 5 and a 0 means 5 will go into both of them. So 5 into 15 is 3. and 5 into 200, 5 into 20 is 4 with a 0. This then is your final answer. Somebody, and I think if you've had a job that where you had to deal with money and you're always good at money, you might have seen there were 3 quarters in 75, and in $10 you would have 10 times 4, 40. So sometimes you could relate this as something you're already familiar with, but I did it this way because everybody, I'm convinced, could do it this way. So this section was about mixing fractions and decimals. And so here was a problem that actually did this. Now, when you see a problem like this, can you do fractions and decimals at the same time? Well, probably not. It would be a lot simpler if it was all fractions or all decimals. Now, the one thing in the parentheses, I really want to do this first. And you look at the instructions. If the instructions say, well, we want this as a decimal for the final answer, or we want this as a fraction, that might steer you one way or the other. But I really want to add these two because it looks like it'd be easy. I'm thinking money again. I'm going to put my 48 cents below this. And this would be 0, carry a 1. I'm getting 0, carry a 1, 8, 1. It's like $1.80. That's better. And so we're not done yet. So I've got to multiply these two. And so I have 2 choices at this point. One choice is to make this a decimal and then multiply it. The other choice is to make this a fraction and multiply it. The book chose to make this a decimal. And so I'm looking at a problem in front of me. 19 over 50, they divided it out. And what they get is 3, 8. This, and I'm doing it quickly because it can be done. It's 0.38 times this. What we have done is taken kind of a messy problem and turned it into something that's doable. And although they're encouraging you to not use a calculator, you know perfectly well that when you use a calculator, decimals work easier than fractions. So as you move along in your math, you'll be using a calculator and that will be fine. What we're trying to do in this course is to get you more familiar with doing things by hand, not so that you always do things by hand, but so that you get your multiplication facts and everything back in your short-term memory so you can do that. So that would be 1.80 times 0.38. 8 times 8 is 64. 8 and 6 is 14. That's a 0. This is 24, carry a 2. 3 and 2 is 5. 0, 4, 8, 6. Now, I did it. I did it kind of quickly, but I did it. 1, 2, 3, 4. 1, 2, 3, 4. I have 0.6840. That 0 at the end is not really needed. And so it's like reducing it. And so we can remove the 0. Now we're down to this, which is a fine answer. Then I would put the 0 in, and I do it last. Just I make sure that there's a number here or a 0 is put in that place. So that's what that particular section is about. What you really need to do is get it all as fractions or get it all as decimals. And sometimes one choice is easier than the other. So let me try this one more. So this is 0.75, this is 2/5. Those two are multiplied. This is adding a half. Sometimes certain things go easily one way or the other. Fractions, decimals, fractions, decimals. And 0.75 is actually 3/4. And so the more you knew a few of these, this is 3/4 of a dollar, or 0.75, 3/4. And so I'm thinking that would be an easy way to go, and then I would still have that. This has to be done first because it's multiplication. And so I'm going to try to reduce this now. So 2 goes into 2 once, 2 goes into 4 twice, and then you multiply across. This is 3 times 1, 3, 2 times 5 is 10. Now, you're not done, but this will finish quickly. We can have a common denominator, and when I'm adding fractions, what I like to do is write them vertically so that I have room to change it into a common denominator. So you look at the larger number, and the larger number is 10, and 10 is good enough for both of them. This one is already done. This is 3/10. 2 will go into 10 very nicely, multiplying by 5. So 1 times 5 is 5. So 5/10 is the same as 1/2. And so now you can just add them. 5 and 3 make 8/10. And you know full well when you see your final answer and you're ready to turn it in, you look at it with a suspicious eye and say, ha, I think I can reduce that. I'll reduce it by 2. 2 into 8 is 4. 2 into this is 5. That's the reduced answer. And I think that was probably the simplest way to go. And so when you look back at the problem, I had a couple of fractions and a decimal that went easily into a fraction. And so that's why I chose to go the fraction way. Fractions can just work just as well as decimals. They should give you an equivalent answer. But anyway, that's what I wanted to do. Any questions so far? I don't know if anybody's attempted some of these. In some of the homework problems, they tell you, do this problem, but they want it in the very end to go to a decimal. And so if they do, like this problem here wanted you to write it, the final answer as a decimal. So you're thinking, it would be easier to stick with decimals. Let's find out. This 2.3 and 2.5 should be added. And so what it is 4.8. Right? We did that first. Then we have 1/2. Now, we could turn 1/2 into 0.5, or we could just multiply this across 4.8 divided by 2. I think that would work. That's the same thing. And then 2 into 4.8 turns out to be 2. 2 into 8 is 4. How's that? So read the instructions, and that will help you a bit to try to figure out what needs to happen, what would be a good choice. That one's not too bad. There is one last section, and it's about square roots. And this is 4.6. Most of these problems are, they will ask you to figure out what I call perfect squares. So the square root of 16, and that's the symbol. So when we squared something, 4 squared, 4 times 4 is 16. There's got to be a mathematical way to reverse it. And so it's reversed with square root. Where did this number come from? So the square root of 16 is asking you what number got squared to get you 16. And the answer, of course, everybody happy with that? What number got squared?
4.
4. And so a lot of these, 25, and then again, we're back to our multiplication table. What times what is 25?
5.
Answer, 5. You see? Now, occasionally they do something weird, but really it's the same thing. What times what is 1? Answer?
5.
1.
Oh,
Square root of 100.
10.
Correct. You see where we're going here? So these become part of what I call perfect squares. The exact, it'll come out, the answer will be a whole number, and you know your multiplication. 6 times 6 is 36. Therefore, you see what I mean? So these are like a special set of numbers. 49 would be 7. 81 would be 9. 9 times 9 is 81. So these are great. The problem about square roots is as follows. I may have to go get more paper. If the square root of 1 is 1, and the square root, people are still coming into this class, the square root of 4 is 2, right? What's the square root of 2? It's not a nice number. It's 1 point something because it's between these two, but it's not a nice number. It's one of those numbers, and I'm going to turn my calculator on. Let's see if I can find it. Oh, here it is. Square root of 2. Now, 1.414213562, and that's rounded. This number goes out to infinity without any pattern. Remember how we saw repeating patterns? No, 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 no. These go out forever. They are called irrational. And that's a pretty good word for it because it doesn't follow any nice, sweet thing. Technically, it means you can't write it as a fraction if you wanted to. It won't work. But so when we get square roots that are not perfect squares, this is your only bet. Well, there are tables for square roots like this, but chances are the simplest thing to do is to pull out a calculator and do it. I'm going to do square root of 3. There is no pattern, and there won't be a pattern to these. Whereas the square root of 4, see, the square root of 4 is 2. It's acting kind of funny there. There it is.
is pi an irrational number?
Is what?
Pi.
Pi is irrational. So so they put numbers into categories, and we had whole numbers which started with 0, 1, 2, 3. We had counting numbers 1, 2, 3, 4. There's all kinds of groups of numbers. And the ones we've looked at so far have been rational. But here's a case for something that's irrational. And so what do? Well, we don't give up. We just round it off to so many decimal places and call it good. Because we can't write the full number down. We can say square root of 2, and then everybody knows, well, it goes out forever. So here's what we're gonna do. So let's try this one. This looks like, so we will take into account what we already know. Here's a 7, here's the square root of 64. There's absolutely nothing between them. That means multiply. So if you know square root of 64, and you know, we do, the square root of 64 is 8. This is a 7. You'd have to put a dot there or parentheses, because otherwise somebody would think it's 78. So that answer is 56. You see how this number is so much better than that? What a mess. This is the one you want, okay? Here's another one. I'm gonna have to get paper. I think I'm on my last sheet. Square root of 9 plus square root of 16. Once you understand this game of what square root means, then it's pretty easy to do, especially if they're perfect squares. Square root of 9 is 3. Square root of 16 is 4. Answer 7. Okay? Even if it's kind of funny, like this one, 25 over 81. Because both of these are perfect squares, you can even do this fraction one. This really boils down to the square root of 25 divided by the square root of 81. I don't think I had to write that step, but the square root of 25 would be 5, and the square root of 81 would be 9. Okay? So this is not impossible to do. We're just sort of beginning with square roots. And if they expect you to use a calculator, then for instance, this one here, square root of 12 is not a perfect square. And so let's say they say round it off to the nearest 100th, TH. So you'd have to pull out this calculator, square root of 12. Whoops, kill that. Square root 12. Okay. So what I would do if I was rounding it to the 100th is write down at least 3.464. And you could go even farther if there's more numbers involved, but to round it to the nearest 100th, using my thing, I'm only going to go out 2 places. This is what makes the decision. It's a 4, but it's under 5, so this does not bump up. This would still be 3.46. Okay. So we won't do too much with calculators, but we definitely we want to at least have you familiar with the fact that you can undo square roots. I'm going to do this real fast. This is a right triangle, and I haven't drawn it perfectly, but this is a 90-degree angle here. And so this has special qualities, and one quality is if I knew this was 3 and I knew this was 4, it could be feet or whatever, could I figure out the length of this? And it turns out there's a formula that does it. And I like old movies, and there is an old classic movie, I think it was made in the 1930s, that uses this in part as part of their as part of the movie. Does anybody know what this formula is or what the movie is? Possibly if you knew what the formula was called. Pythagorean theorem. it was given credit for by a Greek, Pythagoras. It's sometimes hard to tell who invented what, but they gave credit to Pythagoras. So it's called the Pythagorean theorem. And so literally the way it works is this, and the two smaller sides, they call A and B. And I say they're the two smaller sides because this long side is always the longest, and they call it C. Anybody know the formula? A, B, and C?
Isn't it A times B, times half or something like that?
No, you're
No.
thinking of the area formula.
Oh,
but
right, right, right.
Pythagorean theorem.
Mm.
A squared plus B squared equals C squared. And the A and the B can be interchanged, but the C must be that longest side, this side opposite the right angle, the 90-degree angle. And so in this particular case, and I picked this problem, A was 3 and B was 4. Okay. So I put 3 in for A and 4 in for B, and I'm going to try to calculate C. So 3 squared, we talked about this earlier, 3 squared is 9. 4 squared is 16. This is working out better than you think, equals C squared. 9 and 16 is 25. What they did, the reason they brought this up is because this is an example of using square root. So if 25 is our answer squared, what is our answer?
25 times 25.
Go the other way.
Uh,
Go the other way.
That's 5.
It is 5. And they use this in building and all kinds of things. You know, when you want to put up a wall, you want to make sure it's perpendicular to the floor. You don't want crooked kind of walls. And so in all kinds of things, you know, where they have levelers and things to try to make things in position correctly, this formula comes in a lot. And so you can write this down. You don't have to memorize this formula, but you see this is very interesting. This particular formula comes up. A squared and B plus B squared equals the long side squared. And you didn't know the movie, did you? Wizard of Oz. Okay, so Wizard of Oz. Okay, so here they go. So they're going to see the wizard, right? I won't sing it for you, but they're going to see the wizard. And one of them wants a brain. Do you remember that? Anybody remember that? They want a brain.
Roman.
So when the wizard gives him a brain, the first thing out of his mouth is this formula. If the sum of the squares of the sides of a right triangle, and he says it really, really, really fast. And it's hard to say what it is, but what is it? It's the Pythagorean theorem. When he got the brain, the sum of the squares of the sides of a right triangle, and it went on and on. It said it so fast, but it sounded really important, didn't it? The Wizard of Oz. So there you go. There's lots of things like that in old movies where they throw in a little, we're talking about Star Trek. No, maybe we weren't talking, but they throw in a little math trivia thing. So how's that?
Good.
So if, I gotta get more paper. Okay. So A practical use for this, they had a building and they wanted a ladder to get up to something. I don't know what it was. And this they knew was 6 feet. And this they knew was 8 feet. And they wanted to know the length of the ladder. So this is a 90-degree angle. So we could call this one A. We could call this one B. And instead of X, I'm going to call it C. Okay, so you want a ladder long enough to get to this. Maybe it's a window or whatever it is, it doesn't matter. So the formula goes A squared plus B squared equals C squared. So A was 6, B was 8, and we didn't know the length of the ladder. Can you see it? Okay. So 6 times 6 is 36. 8 squared is 64. Okay, so you're using this. So 36 and 64 happens to be 100. So the length of the ladder is a square root of 100, which is
10.
exactly right. So we need at least a 10-foot ladder to make it. And can you see where this might turn out to be
Useful.
useful? I once took a bunch of students, we're not going to do this on Zoom, but I took a bunch of students outside, and we wanted to estimate the height of a tree. And so literally, we were using right angles. Now, we could do this mathematically. So here's a tree. We could do this math. Either somebody has to climb that 50-foot tree, or we can do it with mathematics. Which do you prefer?
Math.
I think we do. And there's all kinds of things where if you can do the mathematics, it's a lot simpler to figure things out than to climb the tree. Now I know I've known people that were really good at climbing trees, but maybe I don't want to do it. You see what I'm saying? And sometimes, I'm gonna do one more. Sometimes the side that's, once you know it's a right triangle, which means it has 90 degrees, then this formula will kick in. Okay. Now, what if we knew that this was 6? Let's just do meters. And this was 5. And we didn't know this side.
So you subtract.
We're going to end up subtracting, yes. And so we're going to use it the formula. And so the missing side is not the longest side. This is the longest side, the side opposite. So this is actually C. This could be A, this could be B. The A and B doesn't really matter. So A, we don't know, A squared. B is 5. And C, the longest side, is 6. Now, I suspect this is not going to come out a whole number, but let's find out. So this would be A squared. 5 squared is 25. 6 squared is 36. We're trying to find A squared for starters. And so I'm going to subtract 25 from each side. So I can just figure out, this is what, 11? So A is the square root of 11. Now, you know perfectly well that's not a perfect square. So what you would do is you would use a calculator to get square root of 11, and you would round it off to the nearest, whatever they say. Okay,
Okay.
all right. So if that was your problem, and they said round it off to the nearest hundredth, let's do that. Hundredth, I would so there's square root of 11, 3.3166, right?
So it's 3.32.
That's right. So hundredth would be 2. I don't know if you like my little thing, it's just an invention I did. 3.32, because the 6 makes the 1 jump up 1. Okay,
Right.
so if it's not a perfect square, you're not going to be able to guess it without using some sort of technology. And so it just depends on if they want it, if they want the answer square root of 11 is an exact answer. This is approximate because it's been rounded, but just kind of follow the instructions. Okay.
Okay.
Now, any question about what we've done? So I would write that formula down, maybe with a little picture. And I think you could probably do that one. This may or may not make a test, but there you are.
Is
It's a
this
good
cylinder,
example. Go
is the
ahead.
cylinder gonna be in the test?
I haven't said if yes or no.
No.
I don't really know yet. So what I wanted to do, let's see, let me go over this way. Okay. Anybody have a question in general from the homework that we could do?
I have one, 3.4 on number 13.
Can you read it to me?
Yeah, it's parentheses 4 plus 4/5, parentheses again, 4 minus 4 and over 5.
Okay, let's start again. So start with the very beginning,
Parentheses
parentheses,
4
yeah,
plus 4/5,
4/5, okay,
parentheses close,
yeah,
parentheses open, 4 minus 4/5.
okay.
I
Okay,
got
so
mixed
this is,
up.
yeah, so this is using multiplication, there's addition here and so on. So 4 4/5 is really like this. So that's pretty easy. And this one, we're going to have to do 4 subtract 4/5. Now, what would probably be the best is to make them both fractions. So 4 becomes 4/1, and this is subtracting 4/5. We need a common denominator. So the 1 and the 5 would actually do it, wouldn't it?
Mhm,
So this is 4/5,
20.
and this needs to be multiplied by 5. So 1 times 5 is 5, 4 times 5 is 20. So 20/5 is the same as the 4 we started with. When we subtract these, 20 take away 4 is 16/5. Now I'm going to write, this is what I tend to do. I do the scribble work on the side, and then I bring it in clean so I can, so it doesn't get too messy in here.
Yeah.
This needs to be turned into an improper fraction, or what I call a simple fraction. 4
It's
times
24/5.
24/5 times 16/5.
Oh, that's what I got wrong.
And the trouble is, nothing cancels.
All right.
So you're gonna have to then multiply 24 times 16 and put it there. 5 times 5 is 25. That one's easy. And so then you work from there. Is that okay then?
Yeah, somehow I got 18/5.
Oh, okay. Yeah, it happens. So what I want to do is come back over here. To our homework. So over here, what you need to do is keep scrolling down. There's a couple of things on the calendar. One, on Friday, same time, 10:30, I'm gonna be on Zoom. And so if anybody wants to come in and we'll just go over problems for an hour or so, then join me on Zoom. This is totally optional, but it might help if you need it.
Yep.
The second test is November 1st, which is the following Monday, and it covers chapters 3 and 4. Now, what's your best bet? Well, the best bet is to finish all the homework. But then after that, come down to the bottom here and test reviews. Do you see it?
Mm.
And so there are, here we go, test 2 review, chapter 3 and 4. I probably should require this because if you don't do it, you're asking for it. I may change this and make it due like Sunday night. I think I will. We'll try it this time and see if that helps everybody.
Cool.
But what you'll do is you just click on this and then it'll be a series of questions and it's what you really need to practice for the test on Monday. Okay? So we definitely have some time. And do you want to work on fractions or you want me to start at the bottom or where do you want me to start? Anybody care?
No.
Doesn't matter. Okay. What I'm going to do, I'm going to grab this problem, 7/30, subtract 1/10. I'm going to grab a couple problems. Let me see if I can get the next one. 1/22 plus 1/33. Let's see. See if I can figure out how to get back there. Gave me trouble. I can do these two. Here was the second one.
33/22. Oh,
No, we need a common denominator. And you may recall one way you can use prime numbers, but sometimes the answer is not that hard to find if you start with the largest one. And when you start with the largest one, you do multiples. 33 times 1 is 33. 33 times 2 is 66. If both of these can be divided into 66, that's your lowest common denominator. And I think I can do it with 66.
yeah.
22 times 3 is what?
66.
56. 1 times 3 is 3.
2.
This would be 2. 1 times 2 is 2. So this method of using multiples, if you start with the larger one, got us there in one step. So I think that was probably the better approach. 5/66. This doesn't reduce, so that would be your final answer. This one is subtract, but in this particular case, the larger one was big enough for both.
Yep.
So you didn't have to go searching. So this is 7. This
Right.
one would have to be brought up to 30. 3. So 7 take away 3, so that because it's subtract is 4/30. And you
Plus
know that
2
every
15.
time you have to look to see if it reduces. So 2 into 4 is
15.
2 and 15. Okay. I'm going to grab a couple more. Let me see if it'll cooperate with me. Too many connections. Well, can anybody get to it? Let me see. What am I trying to do?
I was having that problem too with the connection.
Where are you?
Yeah.
Oh, okay. I'm going to stop sharing. I'm going to stop the recording because we're in a spin. But I did say what I needed to.